Welcome to algebraic equations. Now we are going to solve one variable problems. All right, let's extend what we learned yesterday. So yesterday we focused on adding and subtracting algebraic expressions, and today we're going to work on multiplication and dividing. Okay, so we have what page are we on here? 480 something, 487, there we go, 487. Okay, Tamra is buying party favors. She chooses pencil erasers that are shaped like pieces of sushi. Each package she buys contains the same number of erasers. She buys 2 packages and gets a total of 8 erasers. Solve the equation 2x equals 8 to find the number of erasers x in each package. Okay, so let's go ahead and rewrite this. 2x equals 8. Okay, so in the previous weeks, we have used substitution in order to solve this problem. And if we know our multiplication facts, we should know what x equals, right? So we could substitute 2, and remember I like to use parentheses for multiplication. So 2 times 4, if I know my multiplication facts, I should know that 2 times 4 equals 8, which is correct, which in that case, x equals 4. But let's suppose for a minute that you couldn't substitute, okay? Maybe you don't know your multiplication facts, or you have this is a different problem, and the problem does not have, you don't know what it is. You couldn't substitute. So let me show you the other way. So let me draw a line here. And let's go ahead and rewrite the problem. 2x equals 8. Well, I can do, and if you watch the Edpuzzle video from Monday's assignment, I can do my inverse operation, okay? Inverse operation, math lingo here, is the opposite, right? So if we are multiplying 2 times x, instead we're going to divide, okay? So if we're multiplying 2 times x, I'm now going to divide by 2. And when 2 divided by 2 becomes 1x. And this is called isolating the x. Remember, 1 is already attached to the x as it is, so I really haven't changed anything here except for I isolated the x, okay? So now x is by itself because 1x is the same thing as x, okay? So now whatever I've done to one side of the equation, this is the same, we've practiced this so many times with fractions. We've practiced this with algebraic expressions and equations. So whatever we do to one side, we have to do to the other. So if I divide by 2 on this side, then I have to divide by 2 on the other side. And remember, division can be represented as a fraction. So division can also be a fraction, because fractions are division. So now I can do the same thing where it is 8 divided by 2, right? So if I go ahead and do that, let's say I don't know what it is, and I divide 2 into 8, I'm going to get 4. So then x equals 4. Okay, remember 1x is the same thing as x, and x equals 4. So I did inverse operation here. So whatever I did to one side, I had to do to the other side of the equal sign. Inverse operation. Okay, let's move on. And for my visual learners, here is the hanger model to represent what we just did. So we have our 2x right here, and we have our 8. And here is our equal sign. Sometimes my thing wants to work and sometimes it doesn't, and now it's driving me nuts because it doesn't want to work. Oh, what's that over here too? Let me erase that. I'm just going to rewrite this whole thing. So this represents 2x, and right here in the middle represents our equal sign. Okay, so again, we're trying to figure out what 4 equals, and in this model here, they have split this up into 2 groups. How many are in each group, you guys? If you said 4, ding, 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 you are correct. 4 is in each group, which means X equals 4. So that represents our hanger model. And then if we look down here for our analyze it, this is the same way that I did it. I used inverse operation right here, and we divide, and whatever we do to one side, we have to do the other. And X equals 4. Okay, page 489. Look at your second hanger diagram. Why are the ones separated into 2 equal groups? So let's go ahead and restate the question. They are separated into 2 equal groups because we have 2x, right? Because of the 2x, which tells us there are 2 groups. Okay, number 2. Why can you use the fractions 2x over 2 and 8 over 2 to show dividing both sides of the equation 2x equals 2 by 8? And that's because fractions are a way to show division, okay? So let's go ahead and put that. Fractions represent division. You guys hear the E in the background? It's my printer. It's taking forever to print. Okay, number 3. How are the steps for solving the equation similar to the steps for solving the problem with the hanger diagram? I mean, it still broke it up into 2 groups, and that's kind of what we did too. So let's just write that. Both divided the amount into 2 groups. There we go. So how many erasers are in each package? There are 4 erasers in each package. And then the second part, how can you use substitution to check your answer? So if you substitute 4 for x, you will get the same answer. Okay, let's go ahead and skip number 5 and number 6 so we can move into actually solving some problems here. So let's cross out number 5 and number 6. Okay, number 7, let's solve some problems here. 4 friends go on a camping trip. They decide to share the cost equally. They spend $27.68 on food and $42 to reserve the campsite. You can use the equation 4c equals 42 plus 27.68 to find each person's share of the cost. What does the variable c represent? Explain how the equation 4c equals 42 plus 27.68 represents the situation. Okay, well, let's just go ahead and solve this, right? So I guess, I'm sorry, I needed to reread. Part B, we actually solve for C. Part A, we're just writing down what does the variable C represent. So text box is what I need. So the variable C represents what? The variable C represents the cost. Okay, so the cost. Now, is it the cost total or is it the cost per friend? is the cost per friend. The cost per friend. Because it says 4C, so we're going to divide that cost by 4 so that we know how much each person has to pay. So let's go ahead and do that for part B. So let's rewrite the equation first. So we have 4C. Oh, I forgot I'm still on text. Ha, ha, ha. There we go. Let's do a different color this time. Okay, 4C is equal to 42 plus 27.68. Okay, before I can isolate the C, and since I don't have any variables on this side, let's go ahead and add those together. So I'm going to do that over here on the side. So 27.68 plus 42. And I'm just going to put zeros as my placeholder. So this is a 7 here. Okay, so I have 8 and 6. And then 7 plus 2 is 9. And 2 plus 4 is 6. So the total is going to be scratch that, 69.68 for them to do this camping trip, okay? But now we have to split it among 4 people. So we're going to isolate the C by dividing, doing our inverse operation. So if we're multiplying by 4 right now, then we're going to do the inverse operation. So we're going to divide by 4. And when we do that, these two cancel out, which leaves C by itself. Because actually 4 divided by 4 is 1. And remember I talked about earlier that 1C is the same thing as just C. Okay, so now whatever I do to one side, I have to do the other. So I'm going to divide by 4 over here. So I'm going to do it in a different color so you can see it better. I'm going to divide 4 into 69.68. Okay, 4 will go into 6 one time, which is going to have 2 left over, and I'm going to bring down the 9. 4 will go into 29 7 times. 7 times 4 is 28, which means I have 1 left over. Here's my decimal. I'm going to move it straight up, and I'm going to bring down my 6. 4 will go into 16 4 times with nothing left over. And then I have an 8. And 4 will go into 8 2 times with no remainder. So C, the cost for each camper, each friend, is going to be $17.42. Okay, let me use the text box so you guys can see that a little better since my pen is not nice. Okay, C equals my money sign and then $17.42. Okay, number 8. What is the solution of the equation 12 times a half yard, or y, I say yard because I'm always so used to y being represented by yards, equals 2? Okay, so let's use a different color here, and I'm going to do it over here on the side. So we have 12, oh, I'm on text box again, I forgot. There we go. 12 times a half. There we go. Yard, or y, I keep doing that, equals 2. Okay, so first we can go ahead and multiply 12 times a half. So what is half of 12? 6, right? So 6y equals 2. So what can I multiply by 6 that's going to give me a 2? Well, I could use the inverse operation if I don't know. So I can go ahead and divide by 6 on both sides. That's going to isolate y and make it y by itself. And then I'm going to do the same thing to the other side. And if I simplify this, because 2 will go into 2 and 2 will go into 6, I will get 1/3. So let me ask you guys, 6 times 1/3 2? It is. Yep. Okay, so then plug it into the first equation. Is 12 times 1/2 times 1/3 equal to 2? And it is. So the answer is B. Okay, number 9. Benjamin ran a total of 21 miles last month. This is 75% of the number of miles he wants to run this month. Solve the equation 0.75 miles equals 21 to find out how many miles Benjamin wants to run this month. So remember when we were doing percentages, percentages can be represented. Let me use a different color here. Percentages can be represented as a decimal, in which case it is right here. So 75 cents, I'm sorry, I always do that. Okay, so 75%, remember, is the same thing. Let me just refresh your memory. 75% is the same thing as 75 hundredths. Okay, 75% is the same thing as 75 hundredths, which means 75 hundredths is the same thing as 0.75. Okay, so let's go ahead and solve this problem. So we have 0.75 miles. Which is equal to 21. Okay, let's go ahead and use inverse operation. So I'm going to, since I'm multiplying 0.75 times m, I'm now going to divide it by 0.75. Because then I'm isolating the m, I'm getting the m by itself. Because that cancels out and equals 1. And 1m is equal to m. Okay, but whatever I do to one side, I have to do the other. So I actually shouldn't have put my m equals right there. So I'm going to divide this by 0.75. So I'm going to go ahead and do my division symbol here, and I'm going to put 21. And since I have a decimal on the outside, I need to move this in order to have a whole number. So 1, 2 times. That means I have to create a decimal here, and I'm going to move it 2 times. 1, 2. And I'm going to replace these empty spaces with my placeholder 0. And my decimal is going to go here at the back. So now I have 75 into 2100. So how many, first of all, I know 75 isn't going to go to 2, and it's not going to go into 21. So now I'm going to do 75 into 210. How many times is 75 going to go into 210? That's the question that we're asking here. So let me say 75 plus 75. I'm thinking 3 times, but let's try it. So 75 times 3. So that's 15, carry the 1, 21, 22, 2 high, so it has to be 2, 75 times 2. And that is 10, carry the 1, 14, 15, 150. So 2 times, and that's going to be 150. And I'm going to subtract. And I get 0 here. This cancels out 1. 11 minus 5 is 6. And I'm going to bring down my last 0. So how many times is 75 going to go into 600? Ooh, it's going to go in a lot more than 2, a lot more than 3. So let's see, what number times 7 is going to be close to 9? 8. Let's try 8. So 75 times 8. Okay, so 8 times 5 is 40. Well, that's supposed to be a 4 up there, guys. It's never working for me. Come on. Let's try it again. Okay, 8 times 7 is 56, plus 4 is 600, so 28. Because remember, our decimal point is after the 8. So, Benjamin wants to run how many miles this month? 28 miles. Okay, here's what you're going to do. You are going to do page 491 on your own. So you're going to do questions number 1 and number 2. If you'd like to do 492, that is completely up to you. But what is required is page 491, number 1 and 2 to extend our learning. If you have any questions, come and see me during office hours. But otherwise, that's it for today. All right. Don't forget to turn in your work, please. I'll see you guys soon.